This is Jun2006 question 3. A particle is travelling in a straight line to find the velocity of the body. So velocity is just the rate of change of displacement. And you could also get away with saying that velocity was displacement over time, provided you explained your symbols. Part B. A car driver is convinced that the velocity and acceleration of his vehicle must always be in the same direction, provided he is driving in a straight line. Give a simple argument to make him understand that this is not the case when the car is braking. Make reference to your definition of velocity in A and to the definition of acceleration. So first of all, what do you need in there? Well, you must talk about velocity and acceleration. And you have to say that about the direction, that the direction is not the same when the car is braking. Also, you must make reference to your definition of velocity in A, which is the rate of change of displacement, and then also the definition of acceleration. So the first thing we'll say here is what acceleration is. And acceleration is the rate of change of velocity. Okay, then you could go on to talk about directions. So you could say that even though this is a positive displacement direction and also positive velocity, if a car is travelling along in this direction but braking, then its acceleration is actually minus, which means that it's directed the other way. It's acceleration in a negative direction because it's still travelling forward, it's accelerating, but its acceleration's the other way. So it's getting that down onto paper is the problem. And so you can say that car is moving in a positive direction. Then displacement is increasing in the positive direction. But velocity is also increasing. Not necessarily increasing, but it's obviously decreasing in this case, but it's still in positive direction as well, since the car is moving forward. Right. However, the velocity is decreasing. And then since A is equal to, I'm just going to write it in equation form, then A has a negative value. Because your final velocity is 0, hopefully, if it's slowing down to 0. So you're going to have a negative value, therefore acceleration is in negative direction. And it's negative because you're moving forward at the same time. So where do you get marks for that? You get 1 mark for that. You get a mark for saying about the velocity being in a positive direction. You get a mark for saying when the car is braking, it has a negative value. I suppose I should have put that in there. So the car is braking. A has negative value. And then the last mark then is for saying that therefore the acceleration is in a negative direction. So there's enough there to get you your 5 marks. Part C. A weather rocket is fired vertically upwards. It accelerates uniformly from a velocity of 50 at time t equals 2 seconds to 150 at time t equals 12 seconds. Draw this on the graph. So from 2 it goes from 50. Put this up a wee bit till you see it. It's going from 50 there up to, at 12 seconds it goes up to 150. And so we're going to draw a line between those two. Like that. And then it asks you, use your graph or otherwise, find the vertical distance travelled by the rocket between t equals 4 and t equals 10 seconds. So it's between, just be careful about this, because I did this before and I made a mistake. I went right up to 12 seconds. So t equals 4 seconds and t equals 10 seconds. And all you're going to do is find the area under your graph. And so I'm going to divide this shape into a rectangle and a triangle. So we're going to find the area under the graph, and the area is half the base by the height, plus then this is the rectangle base by the height. So for the triangle, half the base by the height, the base is from 4 to 10, so that's 6, and the height is from 70 up to 130, which is 60. 70 up to 130, which is 60. So that is going to give you half of 6 is 3, 3 60s are 180. And then the second part of it, the base by the height. So the base here is, again, it is 6, and the height is, reading across there, it's 70. So it's 6 times 70, which is 420. That gives you 420. And then when you add those two up, you get 600 altogether. So just be careful to read the question. The times are 4 seconds and 10 seconds. And don't make the mistake like I did originally. I shaded right up to 12 seconds, which isn't right. And that's the end of that question.